Awesome.
All right.
Hi.
So, how are you doing, my good sir?
I'm alive and slightly dangerous.
All right. So, I just want to let everyone know this is a Brass Exchange with Mr. Brass, and I'm here with a Facebook buddy of mine. His name is Stephen King.
Yeah.
Can you tell people about you?
Hi, my name is Stephen Paul King. I have no relation to that horror story writer. Just a coincidence of names. Um, yeah, I have an interesting story. I grew up as a oldest son of missionary parents living in Puerto Rico. That was interesting. So I'm fluent in Spanish with a Puerto Rican accent, that comes in handy. Um, I learned how to teach myself. Uh, I was homeschooled, mostly homeschooled, and I read many books. Uh, I learn slowly. Takes me a while to understand something, so I just say, well, until I understand something, it's safe to assume that I'm an idiot in the subject, so I'm prone to say dumb shit. Anyway, yeah, I don't have any kind of
Yeah.
college degree. I don't have a college degree. It takes me forever to do my homework, and that's hard. It's hard to do homework in college and work, and yeah, so I basically just taught myself and made lots of friends and mentors. Um,
Mhm.
I've studied mostly. My interests were re religious studies, where I followed the work of Joseph Campbell and others. I studied all kinds of religious systems and how they worked. And that got me into psychology. And I've studied the work of William James mostly. I didn't get into Jung or Freud that much. I thought William James was good. And from there, got into philosophy. And I was very happy to be able to read Descartes. Um, I read all of Descartes' stuff and was particularly fascinated with meditations, where he
Mhm.
identified the only thing we can be certain about, and that's our own existence. Everything
Mhm.
else is subject to some kind of question mark because you can't verify it. You can't be sure. The only thing you can know for sure is that you exist. That's it. And the particulars of that existence are themselves subject to question. But yeah, the fact that you can
Mhm.
ask the question is proof that you exist. But who you are, that's harder to figure out. Anyway, so and I used my Facebook page to write notes um, about ideas and eh, hopefully engage with intelligent people I can learn something from. And because I'm interested in ideas, I'm not really interested in personalities or sports or whatever. I'm a typical nerd. Yeah.
I
And
remember. Oh, yeah.
go ahead.
I remember that you generally talked about stuff like quantum mechanics and stuff like that, too.
hmm 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 Yeah.
What got
Understanding. Go ahead.
what got you interested in that?
Uh, just general interest in science. Um, Reading books. I've been very fascinated with the work of David Bohm. I read all of his stuff, all of it. I read some of the fringe people like Rupert Sheldrake. That's interesting fellow. But the main science people, I read, of course, Hawking's Brief History of Time. I wasn't very impressed with that. I much more was impressed with Penrose. Roger Penrose's book, The Emperor's New Mind, was quite interesting, quite revealing, and it got me thinking, I need to learn physics. So I got the textbooks. I got David Bohm's textbook on quantum mechanics, and I got some other one. I don't remember what it was. and I went through it and understood it as best I could.
Mhm.
And then I got Misner, Thorne, and Wheeler's Gravitation book and went through that until I had a good working understanding of what the theory of general relativity was about, what the geometry is. And then I got further into mathematics in order to understand what these concepts like what's a set, what's a manifold, what's a point, what are all these abstractions. And then that got me deeper into philosophy where I got into metaphysics. Metaphysics is about the ideas that underlie everything else, like notions like what is existence, what is reality, what are these words that we use, what do they mean? How is it that a word has meaning? How is it that a noise that I make with my face can have a meaning? How's that? Okay, we just take it for granted, but we don't have any explanation for it that makes any kind of sense. Not only does ideas need to not only make sense, but sometimes they don't make sense, but you can find evidence for them that there's something going on, and okay, we go from there. So quantum mechanics is mostly this stuff I pick up here and there. I try to pay attention to the experiments that have been done, so that to make sure that my understanding of a theory tracks with the data of the experiments. Okay.
So I was wondering, you talked about Bohm.
Mm-hmm.
So I'm assuming you know about Bohmian mechanics or pilot wave theory, as it's called.
Uh, yeah, but I'm not really interested in it that much. I find it less I don't find it a very useful interpretation. It's usable. It's useful if you're using a particle based picture of the world, but I don't. I don't use a particle theory. Okay, I don't use a wave theory. I don't use a field theory either. I use more of an emergent and a process emergent way of thinking. And the fields, the particles, and the waves all emerge from underlying processes. That's the way it works. So I'm using an alternative interpretation for my
Well,
ontology,
I
and then
know,
you go ahead.
yeah, because I know Bohmian mechanics is very like deterministic and not really. I think it's observer independent.
Okay, sure.
I'm thinking,
Okay.
yeah,
Well, maybe we can talk. Maybe we can concentrate on something for a second. Let's think about this word determinism. What do we mean by that? What do you think that means? Determine when you say something was determined. Could you give me the definition, or what other words could you use instead of determined that have the same meaning?
mm. I know that like yeah, basically from what I've heard about determinism and
Hmm.
it's that like all events, including human actions and the like, are just inevitable results of preceding causes and natural laws.
Sure, sure. But that I think that's a mistake. Okay, because it assumes that the rules are invariant to scale. That the scale at which you're talking about doesn't matter. Okay, and that's just clearly wrong. Okay, we don't use particle physics to describe the biology of frogs. Okay,
Mm,
right? We don't
yeah.
we don't use the behavior of wind currents and precipitation and clouds. Okay, we don't use that language, meteorology. We use that to talk about the weather. We don't use that to talk about subatomic particles. Okay, so here the point I'm making is that we have different scales of phenomena. We have the phenomena that we see in our everyday life. We see cats and beds and chairs and houses and cars. Okay, and we have certain kinds of stories that make sense using those entities. Okay, when we're trying to talk about so-called subatomic particles, then we realize that we have a story with very scant everyday information in order to support that story. Okay, because we can talk about particles as if they're little balls, right? That bounce off each other and do this and that. But then we have a hard time explaining, well, how is it that these little balls that bounce around seem to show patterns that don't make sense for individual balls bouncing around, such as the two-slit experiment. Okay, in the two-slit experiment, we can fire electrons one at a time through a screen, through a barrier that has slits in it, two slits in it, and then you have a screen, a scintillation screen behind it. Everybody knows this experiment, and you get this pattern. Okay, and this pattern makes no sense if the world's just made of little balls that bounce off each other, and that's it. There seems to be a causal efficacy that comes from a pattern. Okay, there's a relationship between the electrons that cannot be explained by just the electron existing. The electron doesn't have enough room to have mechanisms inside of it that tell it what to do. Okay, so determinism is an idea. It's part of the story we tell ourselves about the world, but it's only really meaningful in the everyday experience. Okay, when we say that person's drunkenness causes car wreck, we're pretty accurate about that. When we say drunk caused wreck, right? So we can say that the accident was determined by the inebriated state of the driver, and the word determined there makes sense, right? Okay.
Yeah.
But if we talk about, if we want to think of the world as built out of basic constituents that you can't divide any further, okay, this idea of the original idea of an atom was that which cannot be divided or that which cannot be cut. That's the Greek word atom, okay, or however they pronounce it. I don't know Greek, so the original concept.
It's all Greek to you.
Well, we could make it in Spanish, but it wouldn't make a difference. Anyway, the idea of a lot of arguments that you hear are just wrong. Okay, they're just non sequitur. It doesn't apply. Okay, the logic of everyday life does not apply to other stories. When we're trying to explain quantum mechanical phenomena, it doesn't work. And some people take that as evidence that, well, there's something wrong with quantum mechanics. No. What's wrong is our failure to understand that the world is not the same, doesn't have the same rules at every scale. Okay? So the rules and the words that we would use to describe stories at different scales are different. When you're talking high energy, high velocity events, you can't use stories that apply to the low velocity, low temperature, low energy scale of things. The world is different. Okay? And we need to understand that you can't just look at the world as if it's made out of this stuff. That you can use the stories about Tom and Joe and his car and etc. Okay, you can't use that kind of sense making at other scales where things are different. Okay, so all this comes to say that we need to be careful with the word determined. Okay, let me give you another word, reality. When we say that something is real, what do we mean? Do we mean that there's a physical version of it, that there's a physical incarnation of it? When I talk about a dog, can I safely assume that there's something dog-like out in the world that goes woof woof? Okay. We would like to think so, but what we're doing there is we're using the definition for physical things that we use in our ordinary experience, and we're applying it everywhere, even to questions of whether something is real or not. So going back to Bohmian mechanics and the pilot wave theory. In pilot wave theory, it's assumed that the particles are real entities, that they have properties, that they are there, independent of observers. Okay, as if observers have some kind of special effect. What is an observer anyway? We need definitions for that. You see, the point of science is about making predictions that can be tested so that we can make sure that the stories we tell and the explanations we give, etc., are backed up by evidence. In other words, because physical evidence is the only proof we have, the only real proof we have that something is true. Okay? I mean, people can think all
Do
kinds of
you
things. They can make all kinds of stories, but it doesn't make them real.
do
Okay?
you a do you have physical evidence for this statement that physical evidence is all we have?
Yeah, I can write a sentence and I can show it to you. I can write it in English, and I can write it in Spanish, and I can ask Google Translate to translate it into another language. Okay, there's my physical evidence. Okay, that's what I have. But that alone isn't sufficient. You have to have two things. You have to have symbols, some kind of pattern in the physical world, and you have to have a meaning that pattern evokes in your mind.
Mm-hmm.
Okay. Now, the problem is that there is not a one-to-one relationship between meaningfulness and thingness. Okay. Does that make sense to you?
Yeah.
That statement?
Yeah, it does.
Okay.
Yeah. I mean, for me personally, I don't really see determinism as that, like, when it comes to decision making and justice,
Uh-huh.
I've gotten to where I've read the literature on it, and I just said, after a while, I said, I don't really think that if determinism was true, it would really change much about our society as we know it.
Mm-hmm. That's true. I agree.
Because the like, for example, there's a common thing about justice
Mm-hmm.
where people say that in order for you to be truly held morally accountable, you it has to be the case that you could have done otherwise.
Mm-hmm. Mm-hmm.
But if you're determined, then you couldn't have done otherwise. And I
Yeah, how
say
about that? Really?
yeah. Personally, I say I like to give the Terminator analogy.
Okay.
Um like in the movies The Terminators with Arnold Schwarzenegger, there's always a big
Mm-hmm.
question over whether or not the Terminators themselves have free will, or if it's
Mm-hmm.
just
Mm-hmm.
deterministic on their end.
Yeah, well, I love the Terminator movie genre. I love it because
Yeah.
it illustrates some very interesting ideas that are kind of prevalent in topics of conversation today with all these chat GPT and the large language models and
Yeah.
words like artificial intelligence, and you see all kinds of stuff in
Yeah.
the social media about that. Okay.
Well,
Um
what I mean is about
mhm,
it is like the Terminator example. There's a big question over whether or not they actually have free will or not, and the the thing is that even if they did not have free will, the evil
mhm.
ones at least, we know that we would have good grounds for destroying them.
Sure, because they want to destroy you. It's, typical. You want to live or
Yeah.
not?
Yeah, so
Okay.
even if they are completely deterministic, that doesn't change, in a sense, the punishment that they should get.
Okay. But all of this is meaningful within the context of a society when you have large numbers of people interacting with each other.
Yeah.
Okay. This is beyond the collective that is the family. First, you have the individual person. Okay? And then
Yeah.
you have the family. Okay? Because people don't just pop up out of the ground. Okay?
Well,
There's a
apparently they
process.
did once.
Well, there's stories to that effect, but we don't find any evidence for these stories, so we can't believe them too much. Okay?
Well, you know,
Yeah,
being made
yeah.
out of.
People honestly used to believe that flies and just popped up. They emerged from shit. Okay, it's like wow, magic. That you have shit and you wait a while and then flies come out of it. It's like wow, cool magic. No, they did a little more investigating and they found no, it's not so simple. Okay, there's these things called flies that lay eggs in the shit, and then the shits turn into worms, and the worms eat the shit and turn into flies that lay more eggs on the shit that repeat the process again. So I've learned to focus on the process involved and not the thing. Okay, because if you just think of the world in terms of things, then you're at a loss to give any further explanation.
Mhm.
So when we talk about justice, that's a second order. That's a second order concept. Okay. Second order in the sense that you can't, it doesn't make you can't give a definition of the concept of justice if all you have is people.
Well,
Okay.
it's
You have
just
to have
us.
people. You have to have people plus the interactions of people. And then on top of that, you have what do the people think about the interactions between people. So that's actually third order. First order is the people, the things, right? And then
Mhm.
second order is the interaction between things. And then third order you have is what the people think of the interactions between people.
Mhm.
Okay. So justice is at this third level, which is what do people think of the interactions between people. And this goes to
Mhm.
value, this goes to economics, etc. But here we have this basic organizing principle of we have at least three layers that we have to deal with. You have the layer of the individuals, you have the layer of the interactions between the individuals, and you have the third layer, which is where we can categorize and make stories about how we think about the interactions between people. Okay, now interactions between people can also include interactions with people with themselves. Okay? Now
Yeah.
is that helpful? Is that a helpful concept to help us
Yeah.
frame questions about justice?
Yeah. I was wondering something as well. You
Okay.
have shared content that suggested that quantum computing is mostly hype, but
Yeah.
you also do know that, like, Q computers can enact controllable quantum states where classical systems cannot. Like, where do you see the
Mhm.
most realistic, non-hyped applications for this sort of technology?
Well, right now we're trying to build what we call a quantum computer. Okay, a quantum computer is like a computer, except the 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 bits are not classical bits; they're quantum. The quantum version is called a qubit, and it can have a spectrum of states instead of just one or its opposite, on or off, 0 or 1. Okay, you use the superposition principle of quantum mechanics. The easiest way to think about superposition, there's two ways to think of it. You can think of it in terms of waves adding together, okay, or you can think it in terms of vectors. A vector is a quantity that has both length and direction. Okay, so
Mhm.
it's a number just has a unit of quantity. How much? Okay, a vector has a how much and a direction. Okay, and then you have another quantity called an amplitude, and an amplitude has direction and amount, quantity, and it also has phase. And you can think of a phase as the twist of a vector that has a twist to it. Okay,
Mhm.
so The quantum computer plays with ideas involving the quantum version of the classical notion of a bit. Now we enact bits in our typical computers using transistors. And what's a transistor? A transistor is a very specialized, fancy version of an electrically controlled switch. That's what it is. It's an electrically controlled switch. You have a switch that when you send an electrical signal at it, it turns off. You send it, or it turns on, depending on what the previous state was. It's kind of like you turning your switch of your light on and off. Off? Okay. And the state of on and off, according is, determines what it is, what state it's in. And you think, okay, so you're instantiating or you're implementing a unit of information in a physical state of a physical thing in the world. Okay. Now,
Yeah.
in order to make quantum computers, we're trying to do the same thing, but with quantum versions instead of classical versions, and that's very hard. That's very difficult to do. A lot of progress has been made, so we actually do have quote unquote quantum computers, but they're nowhere near everyday use. Okay, they're kind of like something that takes lots and lots of money to create, has to operate at very, very low temperatures. This isn't something that you're going to be able to buy you can't go to Best Buy and get you one. No. Another problem we have, why most of what you see about quantum computers, why most of it is hype, because people are trying to attract investment in the research, and that's a good thing. We need people, if they have money to invest in this technology, that's wonderful. Because if nobody invests any money on it, then we can't buy the stuff to make the supposed quantum computers and see what they can do. Science. The hardest part to understand about science is that it's not for free. It doesn't happen for free. Okay.
Yeah.
Things have costs. Things cost, and the value of you have the cost and the value. They're not the same thing. The cost of something is that how much you have to expend in energy and work, etc., in order to get something done. Okay, the value of a commodity, but whether it be a service or an item or whatever, is the most somebody's willing to pay for it. So it would be the value somebody else has for it. Okay.
Mm-hmm.
So we need. This is where economics plays a role in science. And you have people like Eric Weinstein always complaining how science doesn't get enough funding. Instead of funding actual science, all this grant money and stuff is just financing people writing papers. And that's become a problem because we can now get the LLMs to write papers for us, and we're basically plagiarizing other people's work without ever giving them credit because I got my LLM to plagiarize for me. So yeah, I look
That's
good.
lovely.
But so what I'm saying is there's a lot of hype about quantum computers. That's just something fancy, something shiny that we can use to attract attention. Okay, it depends what you're into. If you're into studying, what quantum computers are, then go for it. Go for it. There's lots of information online about what quantum computing actually is, what programming means when you're using a quantum computer. I'm interested in how we think about the interface. Let's say we had two different quantum computers, and we wanted to set up a method for them to send messages to each other. How would we do that?
Yeah, that's interesting.
Because you see, here's the problem: when you allow two quantum systems to interact with each other, they become one quantum system. They merge into each other. Okay, you can't think of one of the problems people have about quantum theory is that they think quantum theory is a theory of things. No, it's not. Quantum theory is a theory about collections of things that we can measure, of properties that we can measure. It's the rules of the properties of what we can measure. That's what it's about. We measure mass, we measure charge, we measure spin, we measure temperature, etc. Okay, and all these properties, spin, temperature, energy, are defined in a particular way within quantum mechanics. And we don't need to get into the detail of quantum mechanics, but the rules are not the rules of everyday common sense entities. They're not, they're different. On the other hand, when you have large numbers of interactions between the quantum systems, large numbers of them, then you get patterns that look kind of like what we see every day. So we explain how this allows us to give a story of how our everyday reality emerges from huge numbers of interactions between quantum systems.
You know what would
Okay.
suck?
What's that?
Quantum elections. It would
Yeah,
suck
who's the
because
observer?
because the outcome would always change depending on who's observing it.
Well, isn't that true? Isn't that true already? Whose poll
Well,
are you?
pretty much.
Who's counting the votes? I am very cynical about politics. Okay, I see politics as the way that people try to gain power over others. Okay, politics is the power games. And what is power in this context? My definition for power in politics and economics, etc., is the ability to get others to do for you what you would otherwise have to do for yourself. Okay,
Yeah.
that's the definition of power. What would be an example of that? How to get others to do for you which you would otherwise have to do for yourself. That has
Tell them there's a
that it.
magic. Tell them that there's a magic man
Go
in
ahead.
the sky. That if they do stuff for them, they'll get rewarded after they die.
Yeah, you get people to believe that, and you could have power. How about that? But
Yeah.
it works because people are willing to believe things just because their neighbor believes it or their friends believe it. And it's strange. It's like, wait a minute, you only believe that because you think your friends believe it?
Yeah.
Isn't that kind of circular?
hmm
Yeah, it is. But that's how our
Yeah.
minds work. That's how our minds work. We believe that people think a certain way, so we act accordingly.
Mhm. Um. Also, I was wondering. I was also going through your Facebook and stuff, and I believe, like,
Hmm.
you talk a lot about the transactional interpretation of quantum
Yeah.
mechanics.
Uh-huh.
Um. Why do you think that would be more effective for explaining the measurement problem than standard quantum theory?
Okay, because it goes to the heart of a notion of interaction between separable quantum systems. Let me explain what that means. Separable means that you can distinguish them from each other so that they have a separate identity. Okay? Now, separating quantum systems is not as simple as taking something, cutting it in half and moving the parts away from each other like we do in everyday life, okay? No. For systems to be separable, then they would basically have to have a state in which they don't affect each other in any way, in a state where they're not entangled with each other. Okay, entanglement is a way of talking about how much one quantum system participates with another. Okay,
Yeah.
um, I did a lot of work with and study with a Japanese professor, associate professor named Hitoshi Kitada, and he was very interested in the so-called problem of time in physics. And he had a very interesting idea. But one of the assumptions he was making is that we could think of the everything that exists as a single quantum system. Okay. Now, what would that would that statement, we can think of everything that exists as a single quantum system? Does that what does that mean to you?
I mean, it is
Just a bunch of words?
pretty much. But I mean, I do
Okay.
find it interesting. Like, that is a good way of seeing it. I hadn't actually heard of that interpretation, but I thought it was
But look,
interesting
okay,
when I read it up.
yeah, it is. Let me get back to it. The transactional interpretation, it looks at the details of interactions between pairs of quantum systems that are separate from each other. They're distinguishable. That there's something about system A that's different from system B. Just the basic concept of they don't have the same identity. Okay?
Yeah.
This is something that appears to be trivial. When you say I have two things, that automatically implies that each of the two things has its own identity. It is what it is, right? And when you say it's this, then it's this, and it's not the other. All these basic details that we take for granted are important. Now, what the transaction interpretation looks at is it looks at how we can represent interactions between the quantum systems. And one of the things it shows is that anytime you have an interaction between quantum systems, you have to think of them as merging into a single system. The two systems become one.
So they're
Okay.
married.
You could think that, yeah. They share properties. Now, that seems to be okay until you realize that there could be properties of one system that are incompatible with the properties of the other. It's like, you can't marry a lemon and the ocean. They're incompatible. Okay? So, in
They have a
order
lot
to,
of
if
problems.
you're good, you get a lot of problems, a lot of friction, a lot of this, that, and the other. And that don't work too well. Okay? But the transaction looks at how when you do have compatible aspects of two quantum systems, that it gives you a way of talking about how the interactions follow from those common aspects, those common properties. You think of them as a handshake. We agree on that this is that. We agree that this other thing is that other thing. So all of the agreements happen within this idea of a transaction. Okay? But another thing that's interesting about this is that it gives you a way of thinking in terms of a single moment in time also. The transaction, we use the word transactional interpretation because we're focusing on individual transactions. Each transaction happens within a moment of time. And that moment of time could last it could last a duration, like it could last 1 second, it could last half a second, it could last millions of years. Okay.
Mm-hmm.
But from the inside, everything happens all at once.
So, I mean,
Okay.
that is actually a question I actually did want to ask you about
Sure, go
time, the
ahead.
nature of time. Well, I
Okay.
mean, I believe you have said that, time is just not a time is emergent rather than fundamental.
Mm-hmm.
What would that imply for like things about causality and how we understand it?
It's a good question. It's a good question. You see, the normal definition of causality and determinism, etc., assumes a single clock for all of the universe. Okay, that everything is. You can think of a moment when you snap your finger, that determines this point in time, and then there's something that happens at that time everywhere. Okay? That's our common sense view of things, because in our everyday life, that seems to be a workable explanation. Okay? But we found out from general relativity and from quantum mechanics that that's just not so, especially in general relativity. General relativity tells us that there is no absolute now. You can't define it. You can't define it. You could try, you could do math where you assume that there's such a thing. But when you really get into the detail of trying to calculate what properties it would have, you can't. It's like, I don't know. The best you can do is you can define a clock. you have a you have a vibrate you have a cesium atom or some atom in some magnetic field, and you process it, and it processes at a certain frequency. Think of it as spinning round and round and round. Okay, and you count how many times it goes round while light bounces between two mirrors or something. You have the speed of light as your standard. Okay.
Mm-hmm.
But the problem is that you cannot extend that local measurement of change to change spread out across the universe. No, you can't do that. It doesn't work. The math doesn't work.
Mm-hmm.
You can do it for an individual moment, for an individual observer, but you can't do it for all observers. There is no such thing as, well, another way of saying this is that there is no special observer that can see everything happening one step in time and then to the next and into the next and into the next. Or, so you have two kinds of observers that we use in our fictional account of the world. We have God that can see everything all at once. Okay? However we want to define God. Or we have the atheist version, which is Laplace's demon. It's the same powers, we just use different words for it. Okay, fine. And Laplace's demon was this entity that supposedly knew where everything was and knew what the momentum was, which is where it's going, and knew what the electrical charges were for everything, and knew what the masses were for everything, et cetera, and then had knowledge of how these properties evolve, which is what we call the law of physics. The law of physics are the rules of how things evolve given some state. And so in that way, they would have knowledge of everything that happens in the universe. The problem is that's not possible. Why isn't it possible? Because you don't have enough memory to store the information about all the properties and the rules on how those properties evolve for everything in the universe.
Mm-hmm.
You follow me?
Yeah, I follow you.
Okay. You're only able to think about things because you have a brain that is implementing all of those bits and qubits that are underlying your mind. Your mind is software. Your brain is hardware. Okay? And the relationship between software and hardware is not one-to-one. It's not. It looks like it's one-to-one if you just look at it very, from a distance. But if you look at it carefully, there are patterns that you cannot infer from just looking at the physical stuff. If you just look at the physical stuff in each place, you can't tell what the pattern is, because the pattern takes time to build up. Okay? Everything doesn't. Another reason we say time exists because everything cannot happen all at once. Some things have to happen first. Some things have to happen second. Some things have to happen third. You have an order in which things can happen. Okay? And because of the relativity of how fast clocks tick, okay, depending on their acceleration, you can have disagreements, like whatever. There's no universal clock. Okay, all we have are local clocks, and whether or not they can be synchronized or agree with each other, so that we can say it's 2:00. Let's get together at 9:00 and have an interview, for example. Okay, we can have agreement between our clocks and our clocks mean something where we are, and they have a value. Okay. And hopefully my value of a clock and your value of a clock agree, and we can get stuff done. So what is time? Okay. It's a concept that has many parts. We have the part of past and present. We have the aspect of time. We think of a flow of time, or one event becomes another in a smooth transition. Okay, we see things moving around. That is a change in their physical state over time. Okay. So what else is mysterious? But is time a thing? No, it's not a thing. No more than a foot or a gallon is a thing. It's a concept. Okay. Time's a concept. It's not a thing. So when you say, does time exist? You're using the wrong words. Of course time exists, but it's a concept. It's something you think about. It's a way of thinking about things. It's not a thing.
Well,
Okay.
a lot of what you're going into, like with the causality and stuff, with time, is that I think it's sort of a B theory of time, or tenseless, I believe.
Okay.
I'm
Go on.
thinking so. And I've always found that interesting because I found that you could still use beginnings in B theory of time like that, because even because like you can use your birthday for example, even if every point in your life equally exists, you can still index this one part and say this is the day you were born. So that's sort of how people have given that thing of time, like on the B theory. Yeah. So I was also thinking about. I remember you talking about the hardware and the software.
Yeah.
I believe that goes into Michael Levin's work on bioelectric interfaces and
100%.
morphogenesis.
Yeah. I'm fascinated by his work. Oh yeah. They're finally realizing that, hey, biological stuff has software too. Okay, it's not just mechanical. So they don't use the word that much, but there's software for the biology stuff. Biological stuff has software too, but it's different from what we normally call programming and code and software. Okay, so what it indicates is that we need better language, but it'll evolve. Well, it'll evolve as more people want to talk about it.
How does that perspective change how we approach things like biological engineering and AI?
We'll see. We'll have to see. These are conventions, as as new experiments are done and people talk about stuff, they develop new concepts, and we'll see. We sometimes you just have to be part of the process or pay attention to the process that's going on.
Yeah, and I know that you talk about like processes and all that, and so I mean I think you sort of answered this but in reading your Facebook post, you often critique stuff like naive realism and substance ontology when it comes to physics. If the universe is not fundamentally made of substances or particles, what do you believe is the primary map or foundation of reality?
Processes, things happening,
Yeah.
events, actions, cyclical actions. Okay, repetitive actions that repeat over and over and over and over and over. Okay, instead of having the world made out of things that do stuff, we have processes that generate effects. A good example of this that I like to use is the concept of temperature. Okay, when we have a temperature, what are we actually talking about? Heat, right?
Yeah.
Okay, something we measure with a thermometer. But what are we actually measuring? What we're measuring is an average quantity made up of the energy of all the little sub-processes occurring in the region where we want to measure the temperature. Instead of thinking of an atom as a thing, we think of an atom as a process involving electron processes and proton processes, neutron processes, electromagnetic processes. Okay, all synchronizing together into what we call an atom. We're here, we're thinking of an atom as a process made out of processes. You can have, what's a process? A process is a system of other processes. What's it made out of? Well, it's made out of other processes. Processes are made out of processes. Now that seems circular, okay, but it's only circular if you assume that you're using normal set theory, where it doesn't make any sense to have a set made out of itself. Yeah, but nothing exists in isolation. So a set is a collection with respect to other things. Anyway,
Yeah.
so does that somewhat answer your question?
Yeah. Another thing that I also was going through and I was wondering about is
Mm-hmm.
you have you've used the analogy of the Rosetta Stone when it comes to certain aspects of mathematics, like
Mm-hmm.
the symmetric monodal categories.
Mm-hmm.
Um, so you've highlighted that as a sort of Rosetta Stone for abstractions. How do you think
Mm-hmm.
category theory could help unify these seemingly unrelated fields like physics, logic, and computer science?
Well, category theory is a mathematical idea where you have a concept of a category. Basically, it's a tool that allows you to relate the. We used to have mathematics for different things, like we had sets and we had vectors and we had geometry and we had angles and trigonometry and calculus and all these different things. But with category theory, as it's being developed, we learned that all of this stuff you have a common language for all this different math. So you can relate things that you normally you would use vectors to talk about. Like, for example, you would use vectors to talk about motion, right? And you would use fields to talk about electromagnetic phenomena. Okay. But within category theory, you can have a single picture that talks about both the vector stuff and the field stuff using a single method. So it allows you to unify concepts and show relationships between concepts that previously you didn't have any way of relating to each other. Okay. And this is what opened my eyes to an idea that I first read about in the work of Von Pratt. He's now retired professor of computer science at Stanford University. He's now retired. He's old. He's in his 90s or something. And back in the 90s, he wrote the 80s and 90s. He wrote a bunch of papers where he was thinking about the mathematics for describing computer chips and how to design computer chips. And he was, working on the abstract theory. And in it, he was using concepts that he would borrow from mathematics as best he could, because all this stuff is abstract. Okay, you can't point at physical things, right? You have to use abstractions like numbers and vectors and etc. But then this is when category theory was starting to really flower, and more people were learning about it. And he used some of the ideas, and he noticed that there's a mathematical relationship between a pair of concepts that looks a lot like what we need to describe the relationship between hardware and software. Okay. And this relationship between hardware and software is very interesting because it allows you to think about what might be the relationship between mind and body. Okay, if mind is something kind of like software, a more general form of software, and the body and brain and all that is hardware, and if we have a way of talking about the relationship between the two, then that's cool. Okay, we can have dualism that makes sense, unlike the dualism proposed by Descartes. Okay, the Descartes' failure. Descartes' failure was in assuming that the world is made out of substances. Okay, a substance is that which has innate, persistent properties. It's a world made out of things that are what they are, independent of everything else. Okay. Now the problem with that is that you have to explain, well, how come we have all these things? So where did they come from? Did they always exist? Because you can't get something out of nothing, right? You can't get something out of
unless you're the
nothing.
government.
Even then, you can't get something out of nothing, even no matter what. Okay, what does the government do? It taxes. Okay, it taxes and it borrows.
They print money.
Yeah, that's borrowing from the future. Okay, you're borrowing from your children. Hey, kids, don't worry about it. You just have to pay for it later. I'm going to use the money now. That's what borrowing is. Okay, yeah, I'll pay for it later. And if you don't, well, bad things happen. Yeah.
So, yeah, I remember you were talking, like, you talked about consciousness and that, and I remember in your post you had talked about bicaramelization. I was wondering if you were suggesting that human consciousness is undergoing a shift backwards to like a more
that wasn't my idea. That was somebody else's idea. It was an interesting thought. I haven't read the paper. Okay, I only know scant a little bit about I scanned through it real quick. I didn't have a chance to get deep into it, but what they seem to be saying is, okay, are you familiar with this? Is all coming from a book by William James called "The Origin of Consciousness and the Breakdown of the Bicameral Mind."
I think so.
Okay,
I know I've seen it on your post.
Yeah. The idea, there's a theory put forth by this guy James or whatever, in this book, The Origin of Consciousness and the Breakdown of the Bicameral Mind. He suggests that at one point in time, the way the mind worked is that you had two minds. You had a mind supported in the left hemisphere and a mind supported in the right hemisphere. And basically, one of them, the idea of voices, the idea of gods and external entities telling you what to do. Okay. And honestly, they're playing. I think this work plays on a kind of misunderstanding of how the mind works. Okay, like If you're software, then how does software interact with other software? How does your mind interact with mine? Do we have a story on how that works?
Through Discord.
What's that?
No, I mean, there's
Rubius.
like you said. How does one mind talk to another mind? I'm saying through
Yeah, how do they
Discord.
interact? Yeah. Well, here in this case, yeah, but we need a more general explanation. We need an explanation that doesn't depend on whether we're using Zoom or Discord or writing on paper and passing notes, right?
Yeah.
Okay, right. Well, what are the obvious things? Obviously, it appears that we have two minds, although I could be hallucinating that I'm talking to you, and you could be hallucinating that you're talking to me, right? But we can play with that. So let's say that I believe that I'm hallucinating that I'm talking to you, okay? And simultaneously, you're hallucinating that you're talking to me. So who's this me? Okay, I have a point of view. I have a hallucination of you. Okay, and this hallucination exists in my mind, right? And then you have a hallucination of me, and it exists in your mind. Well, what if my hallucination of me matches your hallucination of me, and your hallucination of yourself matches my hallucination of you? Then that works because I'm hallucinating that I'm talking to you at the same time that you are hallucinating that you're talking to me, and yet somehow our hallucinations progress in a way that looks like we're talking to each other. How about that?
Yeah.
Now, what's interesting about this is that we don't have to mix minds in our explanation. I don't have to actually know what you're thinking. I just have to pretend, intentionally or subconsciously or unintentionally, have a model of you, a hallucination of you, a theory of you, or a theory of people that I can set it up so that it acts kind of like I expect you to act, right? And you do the same for me. Like all you know about me is what you've seen from what other people say about me and what you see on my Facebook, right? You don't know what I had for breakfast, right?
Cereal.
I did. Nope. Wrong. Anyway, but you don't need to
That
know.
would have been funny. That would have
Okay.
been funny as hell if I would have gotten that right.
Yeah, but then I'd ask, well, what kind of cereal? Was it Captain Crunch or was it Choco Puffs?
Frosted Flakes.
Was skim or full or whole milk or maybe half and half? Who knows? Okay. The
Yeah.
point is that as long as our hallucinations of each other align, then we can appear to be operating in a same world and have similar enough meanings of things to be able to appear to be interacting. Okay. And if we can explain what we can measure, then we're good. We don't need to assume anything else other than that. So you could use a hallucinatory theory to explain how it is that we're having this conversation in Discord. And I'm
Yeah.
suggesting that that's actually what happens.
Mm-hmm.
And I point to the work of Carl Friston and others, the free energy principle, as support for this way of thinking. There's very good theory about how this would work. Okay, so that but what it implies is that we have to think of interactions between minds in a way that doesn't involve this idea that information is a substance that gets moved from one place to another. Okay, information is agreement about
Isn't
that
it an
such and
almond
such.
agreement?
Yes, it is. I use Allman's agreement theorem. That's right. That's right.
Mm-hmm.
It's Yeah, but Almond agreement, Almond agreement, as it is standardly explained, requires the notion of a Bayesian reasoner, and that has its own baggage that has to be explained. Okay, because a lot of people will critique the Almond agreement explanation for conversations, etc. Is like, wait a minute, do we actually have? Well, yeah, we kind of do. How complicated of a process do you need in order to have an instantiation of a Almond reason or of a Bayes reasoner? Okay, because Almond's agreement theorem basically states that systems that can implement a Bayes process, where you have you have assumptions about the world, and you have a way of evaluating new information, and a way of updating one way or another your beliefs from the prior to the posterior. Okay, so you have what you believe is true now, and then you're given new information, and that supposedly allows you to update your beliefs. Your beliefs are the things that you take to be true. Like you believe that you are Guru, right? That you have a name and that you live in a particular place and that you're talking on the you're talking on Discord to some guy named Steven, right? These are things that you
Who is
believe
it?
to be true.
Yeah, who is it? The scary movies writer. I mean, the scary
That's
book
that's Stephen
writer.
King. That's Stephen King, the other guy. Not it's not me. I'm not that guy.
You have his money.
I, I don't covet his money. Okay, he did what he did what he did, and he was rewarded accordingly. Good for him. People value his work. They're willing to pay for it. Hey,
Hmm.
I don't. That doesn't entitle me to anything,
Hmm.
right?
Um, yeah. I also remember, like on your Facebook, you had like a profile mission thing that says, "Don't seek intelligence in the universe, seek to inspire it."
Oh, good. You noticed that? Yeah, yeah.
How do you think individuals can inspire intelligence in the universe?
By asking questions and trying to find answers to those questions.
Mhm.
By studying ideas, trying to understand better what they think they know.
Mhm.
Don't take things for
I also
granted.
know that yeah. I also know you identify as like a talent agent, I believe.
Yeah, talent agent for the basilisk. Yeah, you
Hmm.
saw that. Cool. That's a bit of a
Yeah.
joke.
Well,
That's kind of an
given
inside
your
joke. Hmm.
yeah, well, given your interest in complex in systems and AI, does that
Uh-huh.
like sort of thought experiment like work for? And what kind of talent do you represent with that stuff?
Well, what's a talent agent? What do you expect a talent agent to do? Somebody gives you a card and it says Stephen King, talent agent for the basilisk. What would you expect me to be up to? Who's the basilisk in the first place?
It sounds like a kind of fish.
No, it's a concept. There's a forum called Less Wrong, where led by Eliezer Zhukovsky. Okay, and it's a bunch of us smart alecks trying to outsmart each other, and
Mhm.
showing off how smart they are. And one day, some participant named Rocco proposed the following. Let's imagine an entity that was the super duper general intelligence, super AI, okay? That was so smart that it knew all the laws of physics and it knew how to tweak things and it knew how to run computations and it could do simulations and then all that stuff, right?
Mhm.
And well, you can look this up. Okay, it's called Rocco's Basilisk, and read the article. Read the articles about it. It's basically an atheist version of God. Literally, it's what it is. Okay,
Mm-hmm.
and it's a joke because there's a problem with this idea. Okay, where you have a perfect observer that can control everything. And, well, what do you mean everything? Can it control itself? Does it know who it is? Okay, and how does it know who it is? Because while it's trying to know what it is, then it is something else. So that is it or isn't it what it is? You get all kinds of circularity problems. Okay, it's like, okay, there are no totalizing observers. Okay, there are no totalizing entities. You can't have a Maxwell demon that can create enough energy by opening and closing a door between two tanks in order to maintain a thermal disequilibrium enough to power the process itself. Okay, are you? Did any of that make sense? Do you know what a Maxwell demon is?
Yes, I know what Maxwell's demon is.
Okay. Well, can you
There's a
imagine
lot
a
of
Max?
demons. There's a lot of demons in
Yeah,
math.
yeah. Well, I only use two of them: Laplace's demon and Maxwell's demon. Okay.
Mm-hmm.
Um, Laplace's demon is this entity that can knows all the laws of physics and knows where everything is in the universe, and so it has knowledge of everything in the universe. Okay, that's cool, but does it know what it is? And how would it? How could it? Well, does it know what it is? Does Laplace's demon know that Laplace's demon exists? No. So that's a weird entity. Okay. Now, Maxwell's demon is this entity that can somehow know. It's a Maxwell demon is a miniaturized version, a limited version of Laplace's demon. Maxwell's demon only knows about what's going on inside two tanks that are separated by a valve. Okay. And the question is can it use that knowledge to separate the molecules that are bouncing around inside the tank so that all the fast ones are on one side and all the slow ones on the other? So you get a thermal gradient between the hot side, which is where all the fast ones are, and the cold side, where all the slow ones are. And it can use that temperature difference to power a computer that runs the demon.
Oh,
You follow?
did I? Did it? Yeah. I remember a
And the
joke
answer
that
is
I actually.
no. Why? Go ahead. Sorry.
Oh, it's fine. You go. You continue.
Okay, you see, the problem here is that you need more resources than you have available in order to perform the processes required to be a Maxwell demon or a Laplace's demon. Laplace's demon is just a super duper version of it. Okay, really, in its capacities. But in Newton in I'm sorry, in Maxwell's demon, you have a particular case where you have two tanks of gas connected by a valve. And then you have the additional idea that I add to it is we'll call it a computational Maxwell's demon, okay, where a computer is using that temperature variation to power the computer so that it can implement a simulation of a Maxwell demon. And the Maxwell demon then, we say, would know the state of all of or it would predict, if it could accurately predict where all the hot molecules are and all the cold molecules are, otherwise known as the fast ones and the slow ones. Okay, the fast molecules are hot, the slow molecules are cold, and if you could separate them so that all the hots are on one side and all the colds on the other, then you could use that temperature difference to power the computer, and the computer implements the software that implements the Maxwell Demon process.
Mm-hmm.
And the problem is that, well, you can't, that whole thing has to create entropy. The process of running a computer creates entropy. Okay, so what is entropy? Entropy is a measure of energy. It's a measure of energy that is not useful to do work. The more entropy we have in a system, that's a measure of how much of the work you can get out of the potential energy of that system. And if the entropy is at a maximum, that means that there's no useful work that you can get out of that system anymore. So we say that the physical system is at equilibrium. And the famous law in thermodynamics is that systems tend to equilibrium states. They tend to a state where there's no more free energy, nothing useful can happen. So you get this idea of stationary processes where it just is what it is. Okay, that's useful. But nothing happens.
Mm-hmm.
So there's no time. Time is measured by a clock outside of it. Well, you got to explain, okay, well, then what's outside of it? And then you have to have an embedding space. And then you get questions of containment that you have to explain. And nothing is ever simple. Nothing is ever simple.
What about that statement?
What? The statement?
Nothing is ever like the statement. Nothing is ever simple. Is that simple?
Seems. No, it's not, because it's embedded in a language that's not simple.
Mm-hmm.
The statement, nothing is ever simple, only has meaning within a language that includes the statement, but that it includes other things too,
Mm-hmm.
right? In order
Mm-hmm.
for a concept of simplicity to have a meaning, then you have to have lots of relationships between concepts. Like when you open a dictionary and you look up a word, rhinoceros, for example, okay, you get a whole bunch of other words that are put together in a certain pattern according to a grammar and the notion of a language. You get this. You might get words like a rhinoceros is a four-legged animal that has a notable horn on the front of its face. Okay, has a single horn on the front of its face. Okay, it's like growing out of its nose is a horn. Oh, wow, cool. Okay, so you kind of have an idea what a rhinoceros is, and you can get pictures. Now, look, we have a four-legged animal with a horn growing out of its nose, the front of its face. Okay, all right, fine. But notice that the definition is given in terms of relationships between words. So somehow
Mm-hmm.
meaningfulness is in the relationships. Okay? It's not in the things. It's in the relationships between the things. So you can't talk about meaningfulness just talking about things. You have to talk about relationships between the things in order to talk about meaningfulness. And again, this goes back to this idea that you need three different layers. You need to have a picture of the world that talks about the world in terms of three layers. You have the things, you have the relationships between the things, and then you have what we can say using language about the relationships between the things. Okay.
Mm-hmm.
So, and we need to be careful that we don't mix these three layers together arbitrarily. Now, to get back to the talent agent for Rocco's Basilisk, that's just a joke. I'm trying to see who picks up on what that is. Okay, because it would tell me, it tells me things about people that might notice that. So I appreciate that you noticed that. Thank you.
No problem. All right, so we've actually been talking for a little more over an hour.
Okay.
So I believe I gotta go walk my dog real quick. So I'm
So
gonna,
this is enough for an interview.
yeah, we hit on all the questions that I wanted to
Okay.
answer.
Well, we can do part two. Okay.
Yeah, you can
We
always
could
do
do it
that.
again. Sure.
Yeah. All right. Well, yeah, that is all for today. This is Mr. Brass saying goodbye and get wise.